Hello everyone, in this class we are going to start working with example of array. Look, here two code segment is given to us and we need to find the output produced by these two code segment after execution of them. Clear? So let's start with, look, this is our first example and this is our second example. In first example, this is our entry point function, so system will start work from this particular function, main function. Now inside the main function we declare one array of integer type. That means memory for this particular array A will allocate from stack section. Here we have stack section, and in this stack section a memory will create for the array A, and it will contain 5 different elements. As the range given here is 5, so this particular memory will contain 5 smaller block of index 0, 1, 2, 3, 4. Let's say the base address is 2011, so A will contain 2011, the base address of A again will be 2011. Now coming to the initialization part. For initialization, as this particular memory block is allocated from stack section, the initial value will be garbage value. So each of these 5 elements will be garbage value. Now the next variable, that is integer I. So this particular, the memory for this particular variable will also allocate from stack section itself. That means inside stack section we will have one more variable I. Let's say the memory is allocated from 3012 to 4 byte memory was there, and again this particular variable I will be initialized with garbage value. Now coming to the next statement, the next statement is again a variable declarative statement, but now the variable is declared as static. So from where this particular memory will be allocated? This memory for the array B will be allocated from data section. That means in memory we again have one more section, that is data section. Now from this data section memory will allocate for the array variable B. Now as the memory for B is allocated from data section, so what will be the initial value? The initial value will be 0. That means each of these element of array B will be initialized with value 0. Now coming to the next statement. In next statement there is a for loop. So inside this for loop, first initialization, that means the variable I is initialized with value 0. That means here in the memory block of I, the new value will updated to 0. Now the next termination condition. In termination condition the instruction given as I less than 5. So what is the value of I? Now the value of I is 0, so 0 less than 5, yes, true. Now as the condition becomes true, so it will enter inside the for loop and execute this printf instruction. So what will be the output here? What will be the output that this particular printf will give us? Look, inside this printf instruction %d is given %d for I. So what is the value of I? The value of I is 0 now. So this is our output. In output we will get the value of I as 0. Now coming to the next thing, that is %d. Now again for this %d the identifier given as A of I. So what is this A? A is our array that is allocate that is in our stack section. Now the index of array is 0. So what is the value of A0? The value in A0 is garbage value. So here we will get a garbage value. Now next instruction is given as again %d. Now for this %d the identifier given as B of I. So What is this B? B is again an array, but the memory allocated for B is from data section. Now the index of B given as again I. So what is the value of I now? The value of I is 0. So here it becomes B0. Now what is there in B0? In B0 we have 0. So it will give us again 0 as result. Now \n is our next instruction. So control come to the next line in the output screen. After that, this particular printf instruction is completed. Now control again jump to the for loop and increment the value of I. Now the value of I becomes 1, and then control come here and check the condition. Now the value of I is 1 less than 5, yes, true. So control enter inside the for loop and execute this particular printf. Now %d I, what is the value of I? The value of I now is 1. Next from where the value will display a of I. So I means now is 1, so a of 1. What is there in a of 1? We have garbage value. So next it will print again garbage value. Now for next print %d in printf, for this %d now the identifier is b of 1. So what is there in b of 1? B of 1 will give us again 0. Again we get \n. So again control come to the next line in the output screen. Again go to this increment statement. Now the value of I becomes 2. After execution of this increment instruction, control comes to this termination condition. Now the value of I is 2 less than 5, yes, true. So again printf instruction will execute. The value of %d, that means I. Now the value of I is 2, and next identifier is a of I, that means a of 2. Now in a of 2 again garbage value. The next identifier specified is b of I, that means b of 2. Now the value of b of 2 again 0. So it will print again 0. Again \n will encounter. So control come to the next line in our output screen. After that it complete the printf instruction for this particular iteration. Next thing, control go to the increment statement and increment the value of I to 3, from 2 to 3. Next come to this termination condition. Now what is there in the value of I? The value of I now is 3. So this condition becomes 3 less than 5. So the value, this condition again becomes true. So control will execute this printf instruction once again. So what is the value of I now? The value of I now is 3. So it will print 3. Now what is there in next identifier? Next identifier will become a of I, that means a of 3. So what it will print? A of 3, again a garbage value. So it will print again a garbage value. Now the next identifier is b of I. So what is there? B of I, that means again b of 3 will be 0. So it will print again 0. Now for \n, control comes to the next line, and then this printf instruction is executed for this particular iteration. Now again control go to the increment statement in for loop. So increment the value of I and it becomes 4. Now again in termination condition, so I that means here it is 4 less than 5, yes, true. So again it will print the printf instruction. So %d I, that means it will print the value of I, that is 4. Now next identifier is a of I, that means a of 4. A of 4 again contains garbage value. So it will print again garbage value. Next identifier is b of I, so b of 4. So what is there in b of 4? B of 4 again 0. So it will print again 0. Now \n, that means control comes to the next line, and then after execution of this printf instruction, then again control go to the increment statement. Now what will be the value of I after this particular increment? The value of I becomes 5. Now in the termination condition, the value of I is 5. So 5 less than 5, it is true or false? Yes, it is false. So control will not execute this particular printf, and control will come out from this for loop. And what it will encounter next? It will encounter the closing brace. That means execution completed, and control come out from this program itself. So what we get in our output, we get all these things as our output of this particular program. Clear? So this is the execution of our first example. Now coming to the next example 2. Now in example 2, again control start execution from main function, and inside main function we declare an array x of integer type, but it is a static array. That means from where memory will allocate for this array? Memory will allocate for this array from data section. Now in data section, memory will allocate for the array x. Let's say the base address is 2011, and what is the range given for the array x? The range is 5. So how many elements will be there? 5 different elements will be there in the array, and index will be 0, 1, 2, 3, 4. The base address we consider it as 2011 now. Now here in this declarative statement we already initialized all the elements. The range is 5 and we initialized 5 elements. So what system will do? System will store each element one by one in the array. So the first element will be 10, 20, 30, 40, 50. Now these 5 elements are stored in the array. That means memory allocation part is completed now. Now the next instruction. Next instruction is integer I. Now look, this is not a static variable, it is an auto variable. So from where this particular memory will allocate for this particular variable? Memory will allocate from the stack section, not from data section. That means in this memory block, in memory we again have stack section, and in this stack section memory block will create for the variable I and initialized with garbage value. Let's say the base address is 2050. Now the next instruction, this is our memory part. Now the next instruction is start a for loop, and in this for loop the initialization statement is I equal to 0. That means the value of I will become 0. Now after execution of this initialization part, it will go to the termination condition part. Now in termination condition part, what is the value of I? The value of I is 0. 0 less than equal to 4, yes, true. So the control come inside the for loop and execute this particular printf. That means now we will get output. Now what this particular printf will print? Look here, %d is there. That means one integer value it will display, and from where it will print the identifier given as I of b. Now look, this is not what we know. To specify the index, to specify the identifier for each element of an array. Before go to the output screen, we will see what is this statement and how system will interpret this particular statement. Now look, to access array, each of the array element, we have two different notation. One is array notation and other one is pointer notation. Where this particular identifier specified, this particular identifier use the subscript operator. That means this one is an array notation. But in array notation, inside the subscript operation, we used to give the index of the element. But here, inside the subscript operator, it gives the array name. So how system will take care of this particular instruction? Look at here. In generally, what we give? We give array name, and then within subscript operator we use index of the element, which element from this particular array we want to access. Clear? So now let's consider the index is I and the array name is ARR. So what will be the instruction here? The instruction will be ARRI. Now look, whenever we use any subscript operator in array identifier to identify an element of an array, at that time this notation is called array notation, and system can't work with array notation. System internally convert this particular array notation into equivalent pointer notation. And what will be the pointer notation? The pointer notation of this particular instruction will be ARR plus I whole as indirection operator, that means asterisk. Now when system will convert this particular pointer notation, when system will convert into this particular pointer notation, look, whenever we use whenever we use subscript operator in the instruction, at that time system will convert it into pointer notation. Now here in this case, the instruction given as I, that means index, and then within subscript operator it is ARR. Now what system will do? Now again system will convert this particular subscript operator into pointer notation, and look what we get here. Here we get I plus ARR indirection operator. Now look, both of these are equivalent. Here ARR is a pointer and I is a integer value, and here also I is an integer and ARR is an array. That means both of these are equivalent. Clear? So ARRI equal to I of ARR, and then ARR plus I whole asterisk. All of these three instructions are equivalent. We can use any of these three instructions to access any element from any array. Clear? So system can work with this particular instruction comfortably. Now coming to the printf instruction again. So we will get the output from here. Now %d, this instruction is equivalent to B of I. So no need to get confused here. Both are same. So we can use any of these two form. Now B of I, that means what is the index value of I now is 0. That means from where it will print the value, it will print from B of 0. So what is there in B of 0? In B, sorry, this one is X, not B. So what is there in X0? In X0 we have 10. So it will print 10 here, and then it will encounter the \n, that means control come to the next line, and then this execution of this printf instruction is completed. Now after execution of this printf instruction, control go to the increment instruction. Now the value of I will incremented to 1. Now control will check the termination condition. So the value of I now is 1. So 1 less than equal to 4, yes, true. So control again will execute this particular printf. This is T for true. %d I, the value of I is 1 from X. That means index is 1 from the array X. So in array X, what is there in index 1? In index 1 the element is 20. So now it will print the value 20 here. Now \n encountered by the system, so control come to the next line. After that control go to this increment instruction and increment the value of I. Now control come to this termination condition. So the value of I now is 2 less than equal to 4, yes, true. That means control again execute the printf instruction. Now now control print the value from index 2 from array X. Now in X array in index 2 the element is 30, so it will print 30, and after print \n, that means control again come to the next line and go to this increment statement. The value of I will increment it to 3. Now the condition is I less than equal to 4. So what is the value of I is 3. 3 less than equal to 4. Yes, true. So control come again into the printf instruction and execute this printf and print the value from index 3 of x array. Now in x array the third index element is 40, so it will print 40 here. Again go to this again go to this increment instruction and increment the value of I and it becomes 4. Now 4 less than equal to 4. Yes, again it is true. Now again printf instruction will execute. Now it will display from index 4. So what is there in index 4 of x array? That is 50. Now it will print 50 here and backslash n again encountered. So control come to the next line. Now go to this increment instruction and increment the value of I from 4 to 5 and then come to this particular termination condition. Now the termination condition is 5 less than equal to 4. Is it true? No, it is not true. 5 is not less than or equal to 4. So this condition becomes false and control come out from this for loop and get this closing brace of main function. That means here the execution of this particular program will complete and we get the output as 10, 20, 30, 40, 50 for this example. Clear? So that is how system will work with array. Clear? So that's it for today. See you soon in next class. Thank you.